Your retail pipeline just crashed because Python tried to load 12 GB CSV into memory. One file, one innocent looking loop, and suddenly OVM killed it. Now your Airflow dive retrace everything. Kafka lag grows, dashboard stops updating. And the scary part, the code look completely normal, and that is just this. This looks perfectly fine until production arrives. At first, engineers love this approach. Read everything, store everything, process everything. But then data grows. 10 MB becomes 10 GB. Now Python allocates memory for every row before processing even starts. CPU waits, RAM spikes, container restart. And here is the worst part. You only needed one row at a time. This is where engineers discovered something important. Maybe we should not load everything immediately. Maybe data should arrive only when needed. And that's created iterators. Look at this carefully. Python doesn't start looping it. Nothing moves. The iterator simply stores, here is the collection and here is my current position. Now watch this. Next of numbers. Python grabs only the first value, returns 1, then pauses. Call next again. Now it resumes from position 2. This tiny behavior changes everything. Now imagine a massive log processing system, millions of events streaming from Kafka. Instead of loading all events into RAM, Python processes one event, then next, then next. Constant memory usage even with huge dataset. But engineers hit another problem immediately. Writing iterators manually is painful. Look at this monster. Too much boilerplate, too much state tracking. This is where engineers get burned. So Python introduced something brilliant called generators. The single word yield completely changes the function behavior. The function no longer runs fully. Python freezes it mid-execution. Literally freezes it. Local variables stay in memory. Loop position stays in memory. Execution state stays in memory. Next time someone requests data, Python resumes exactly where it stopped. Think about how insane this is. Function normally die after return. Generators survive. Python secretly stores current train number, local variables, iterator state, stack context. That's why generators are perfect for streaming systems, large ETL jobs, API pagination, real-time consumers. You process data continuously without exploding memory. But then production creates another problem. Every pipeline now needs logging, retry handling, timing, authentication, and monitoring. And engineers start copy-pasting the same code everywhere. Every function becomes polluted with the same operational logic. This gets ugly fast. So Python introduced another idea called decorators. Watch this. The actual business logic stays clean, but Python secretly wraps a function. Before execution, logging starts. If failure happens, retry logic triggers. After completion, metrics get recorded. Internally, decorators are just higher order functions, function wrapping other functions. But operationally, they changed backend engineering forever. Airflow, fast API, authentication middleware, observability systems uses the same idea. See the pattern? Iterators solved memory pressure. Generators solved painful iteration state management. Decorators solved orchestration chaos and business logic. One engineering pain created next abstraction. And the next problem gets even more interesting. Because eventually engineers realized even generators leak resources sometime. Database connection stays open, file never closed, network sockets hang forever. And that's why context manager exists.